Hello everyone, hope you guys are doing well. Well, this is our last video for grade 11 for the mock exam of the final exam Spring 2024. So we will start with the question 1. It says we have two amino acids undergo a condensation reaction. Calculate the molar mass of the one of the amino acids if it's known that the molar mass of one of them is 75 grams. Now, in here for the first question, we know that we have A and B amino acids. They connect together, make a dipeptide, and then we have 1 mole of water coming out. We know that one of them is 75. Let's say this is the one, the other one is X, and we have 1 mole of water, which is 18. We know that both sides gotta equal to each other. And so we have in here the dipeptide molar mass is 146. So basically 75 plus 6 plus equals to 146 plus 18. And this is 164 and X is 89. Okay, so that is the 89 molar mass of the amino acid. And amino acids, we know that the structure is always like this: NH2, CHR, COOH. Now, if you want to find what type of amino acid is this, although it's not asking in this question, we know that this portion in here is 16, well, this one in here is 13, and this portion in here is going to be 12 plus 30 to 44 and 45. So altogether this adds up 58 to 74. Like all this portion in here is 74 molar mass. Okay, and then we're left for 89 minus 74, so we have in here 15 grams left for this R. So it could be CH3, which is 15 grams, so one of the amino acids could be, but it's not asking over here. So let's move on. Now question 2, it is telling us calculate the mass of water in condensation reaction if 3 of the same amino acids were used, if it's known that the molar mass of amino acid is 89, while the mass of the formed tripeptide is 46.2 grams. So now I'm going to write it in here. So we have same amino acid adding up in here 3 times, so 3A giving you A plus 2 water. Now in here we have amino acid which is 89 grams, so this would be 89 multiplied by 3, and then and it says while the mass of the formed tripeptide is 46.2 grams. So now, like in our, according to our balanced equation, we have 89 times 3, and we have 2 waters, which is 2 times 18, which is 36. 89 times 3, which is 267. So if we want to find the molar mass of the tripeptide, it would be 267 minus 36, which is 231 gram. Now these are the values we have. Okay, so we're gonna delete everything else. So this is the one we have, so 36 grams for that. Now let's say you're given a case where 46.2 grams of tripeptide is made, okay, and then now it's asking you calculate the mass of water in that case. So they're asking for the mass of the water, so we put X gram in here. So now this is your condition. You will do cross multiplication to find it. 231 times X, 46.2 times 36, X would be 46.2 times 36 divided by 231, and they will cancel each other out. This would be 5 over 1, and this would be 7.2 grams of water. Now that is the question 2. Now we're moving on to the question 3. It says calculate the molar mass of an amino acid if it's known that during hydrolysis of 113.4 grams of tripeptide, 135 grams of the same amino acid were produced. So let's first of all write our question, whatever we're given. So we have a tripeptide where it goes through hydrolysis, so we need to add 2 moles of water to break it down because we have 2 peptide bonds, right? So this will give us 3 of the same amino acids. Now we know that for here, we're given in this case 113.4 grams of tripeptide. So we have 113.4, and then we are making 135 grams of that, okay? And they're asking us to find the molar mass of amino acid. So basically what they want to find out is the molar mass of one of the A's, okay? So in this case we have 3 of the A's. So we know that according to mass balance, like this side got equal to this side, right? So in here, if we want to get the mass of the water for this specific case, it would be 135 minus 113.4. It would be 21.6 gram of water. So this is the one we have. Gram. Now, we know that according to our balanced equation, 2 moles of water, it is 36 grams of water. Now, what they're asking is to find the molar mass of A. Like in this case, we'll create 3 of the A. So we're going to write here 3x. So, and then we will find the molar mass of it by doing the cross multiplication. And this would be 3x multiplied by 21.6 equals to 36 times 135. X would be just 36 times 135 divided by 21.6 times 3. Now in here, if you will do the calculation, 43 and 135 will give you 45 and 1. And then from here, you will do the math, and this will be 25 gram. Sorry, it would be 75 grams. Now we know that if we write this again, the amino acid formula, NH2CH and then COOH in here, all this portion is 74, right? And we're left only 1 for R, and this would be just a hydrogen, and that's what your amino acid is, although it didn't ask for the formula. Now question 3 is done. Now let's move on to the question 4. Now in here it says a sample of vegetable oil, 5 gram, has reacted completely with 38 centimeter cube, this much concentration iodine solution. It's asking what is the iodine number of the oil. Estimate the average number of carbon-carbon double bonds per molecule. If this oil, there's a grammar problem. Average molecular mass is 865 gram per mole. Now, we want to know iodine number. Iodine number is basically 100 gram oil will require X gram of iodine, okay? X gram of iodine. So in this case, that's what we want. Now let's get this one here. So we know from here that in this case, we have the volume. This is the concentration. And we are given the 5 gram of it, right? So now using the concentration, V is 50 centimeter cube. Now, if you want to convert it to decimeter cube, all you need to do is divide it by 1,000. And this would be decimeter cube. Your concentration you're given in here is 0.5 mole per decimeter cube. So the mole amount of iodine would be just C times V, which is 50 over 1,000 decimeter cube, multiplied by 0.5 mole over decimeter cube. Now in here, decimeter cube and decimeter cube cancel out, And what we're left with is 0.5 times 50 divided by 1,000, which is 0.0225 mole of iodine. Now, if you check out the periodic table, the molar mass of iodine is 254 grams. Now, if we want to get the mass of the iodine, it would be just a mole multiplied by molar mass. So this was the 254 gram per mole multiplied, this is the molar mass, multiplied by 0.025 mole. Now in here, mole and mole cancels out, and you get 6.35 gram of iodine. Now, we are given in this case that 5 gram of oil requires this much iodine, and we figured out that this much iodine is 6.35 gram. And they only asking for iodine number, so this would be basically, so this is going to be basically 5 gram of oil requires 6.35 gram. So you would do cross multiplication like this, and x would be 100 times 6.35 divided by 5. And this would be 127 gram iodine, which is the iodine number. Now, in our cases, like when we wanted to find the iodine number, we would also, has to do with like amount of double bonds, right? In this case, we right away figured out the mole of iodine using concentration and volume, right? We did the concentration by volume. We got our iodine mole amount, 0.025 mole. And this was required for 5 gram of oil. Now, if you're given in your case a compound, now in this case you need to take a look at the number of double bonds, right? So let's say you have a molecule. We know that, let's say it has 2 double bonds, right? And now in this case, whenever you break one, it will require 1 mole of I2, right? To break one double bond. This one will require 2 mole. So altogether it will be 2 mole of I2. Now that's how you will go from here, and you will find the molar mass of iodine by multiplying it by 254 gram per mole, and you will get the iodine mass. And then you will do the proportion again, like whatever the mass you got per amount of oil, and you will get it, the iodine number. Okay, so you just need to practice. The main thing is that understand the logic behind this. I want you to also review our material on the iodine numbers. Now, the question 5, it is asking the formation of valine. This is your CPA question. We had it. Now, this is the valine. You can find it from the table. Also, like, we can actually name this too. We know that valine, it would be, so the first carbon is this one in here. Second is this, third, and this is the fourth. Now, that's the longest chain, right? So we know that it is butyric or butanoic acid. Butanoic acid. Right? And then, so we have on the second one, we have amino group, and on the third one, we have a methyl group. So it would be 2 amino, 3 methyl, butyric or butanoic. Either one is fine. Okay? And it's asking you write the complete reaction formation of valine. So we have done this with you guys, that in here we can use a hollow derivative. Hollow derivative meaning instead of ammonium, we're going to put we're going to put one of the halogens. So let's say we put it like this with the chlorine instead. Okay, now if I'm going to add ammonia to it, so a hydrogen, the way it looks, the NH, H like this. Now chlorine and hydrogen together, they will make hydrochloric acid, and then this bond in here, the one that is broken, will attach amino group to itself. So this will look like that in the end. Okay, so the other name for the valine, we wrote it here. I want you to practice for the other acids as well. Now 5 is done. Now in this question, this is also from the CPA. You can recognize that this is a silver Miller test, so this is like an oxidation. So we have this oxidation in here. The copper oxide, this is also an oxidation. We have done like a similar one with the Benedict test. So this is also an oxidation step. Now in here, the only lead we have in here is propyl acetate. So we know that acetic acid was like this, right? Now when you attach propyl to it, it will look CH3CO with O, CH2, CH2, and CH3. Because propyl is 3 carbons, right? Now, this is a esterification reaction. Now, we know that propyl acetate was made, in here, there is an oxidation where silver mirror test makes carboxylic acid. So we know that A is going to be acetic acid. This is our A because it was formed by oxidation. And then B is going to be just the aldehyde version of that. Aldehyde version of this. Now this one happened in B, another oxidation. Now this one came from CH3, CH2OH. Okay. Now from here, what we did an oxidation step where we removed 2 of the hydrogens and we made this aldehyde. Okay, so the way it was looking, so F is in here, it's going to be ethanol. This is ethanol. And this one is ethanoic, or the other name is acetic acid. Acetic or ethanoic acid, the one we made. And then here on top of this A, we add calcium bicarbonate. We know that we will make calcium ethanoate. And the way it will look like CH3CO negative, and there would have calcium in here +2 with another O, CH3 like this. Now, the last step in here is a sodium oxide. Sodium oxide, when it was added to ethanoic acid or acetic acid, you're just going to get sodium ethanoate or acetate, or sodium acetate. This would be CH3CO negative and sodium plus. And there's a water, of course, coming out of here. And E is, I forgot about it, it is propanol. It had to be an alcohol coming from here, propanol. Now, sometimes when we write this reaction, we write just a plus side, and we don't write all the other products that are coming out of here, right? Because when I will write a reaction like this, for example, silver nitrate. So we have ethanol, CH3, COH like this, and I write in here plus silver, right? I'm gonna make plus silver, and I got this CH3COOH. But as you see, I didn't write the precipitated silver. So I should have written this here. But sometimes what we write, we wanted to indicate the silver, we will write minus in here, meaning that the silver was generated here, okay? So whenever you see a minus like this, that means it was generated on the product side, okay, product side. Well, this plus on the top, it is the reactant side, right? Okay, and that's it for the question 6. Now the next question we have in here is the question 7. It says, in the lab, student conducted butyric fermentation. Calculate the mole amount of released gas if 900 grams of reactant was used. Include the fully balanced reaction in your calculation. Now this one I will write it in the bottom. So butyric acid, we know that butyric acid fermentation, it starts with glucose, C6H12O6, and we make in here butyric acid, which is CH3, CH2, CH2, COOH, and there would be 2 moles of H2 and 2 moles of CO2. Now we are given, this is the question 7, we're given in here 900 grams of reactant. 900 grams of reactant, this is basically the glucose. So I write here 900 grams. We know that the molar mass of glucose is 180 grams per mole, right? Now, that is for 1 mole, and it is asking us how much, what is really mole amount of released gas, like their mole amount of both of the gases. Now, as you see, when we use 1 mole of it, we create 4 mole of gases. Do we agree? Which is 180 grams. So 180 grams of glucose releases 4 mole of gases. Now in this case we use 900 grams, which is just 5 times more. This would be X mole of gases. And this would be, if you do the calculation, it would be 20 mole. 20 mole of gases. Now question 7 is done. We're moving into the question 8. It says 232 grams of 2,2-dimethyl butyric acid reacts with calcium bicarbonate. Write complete balanced reaction, calculate mass of salt formed. Now first of all, we need to take a look at this one. Now we have 2,2-dimethyl butyric acid. I want you to see that butyric means 4 carbons, right? And then 2,2-dimethyl, now this means 2 methyl group, each one is 2 carbons. So altogether we have 6 carbons. The formula of carboxylic acid is CnH2n plus 1 and then COOH. Now, if you have 6 carbons, you know that in here it is 6, H would be 13, and this would be COOH. That's the 2,2-dimethyl butyric acid. Now the molar mass of it, molar mass of this would be 6 times 12 plus 13 plus, sorry, I made a mistake in here. So in here we have altogether 6 carbons. So that means we have C5H11COOH, because I need to include this carbon in here as well. C5 and C. in here, so all together. So the molar mass of this would be 5 times 12 plus 11 plus 12 plus 32 plus 1. Now this would be 60 plus 11 plus 44, 45, and then together it would be 5,616 gram per mole. Okay, now you're given 232 grams of that. That means just basically 232 divided by 116, it would be 2 moles. Okay, now we have 2 moles. Now all this calculation was there for us to find out the molar mass. Now we could have done it by just throwing the structure too, so which is what I'm gonna do in here. So this is the question 8. We have butyric acid C like this, and then 2 so I would put here CH3 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 here and CH2 here. Now you could have just done this through here and you will find 116 gram of that. Now in this case we're adding calcium bicarbonate on top of this. So what we will get from here is, so CH3 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 like this, CH2 CO O negative, and we have a calcium in here in the center, and then COCH2 C CH3 CH3 and CH3, and then we on top of this we are making H2O and CO2. Now we need to balance this out. As you can see, we have to use 2 of this acid in order to have the bottom product. We use 1 of the calcium, that is good. So 2 of the acid on top, everything gets used but this hydrogen, right? Those 2 hydrogens are getting combined with HCO3. H plus HCO3 combined, and we get H2CO3. But there's 2 of them of each, so we will make 2 moles of each in here, and that's what our reaction would be. Now the question was asking us that what if you're given 2 moles of this acid, and it was asking you to find out mass of salt formed. How much of the mass? So we know that if as we can see in our balanced equation, 2 moles of that gives us 1 mole of the salt, right? So all we need to do is to just find the molar mass of this salt. Now we already found out 116 was the whole acid, but we lost 1 of the hydrogens, so it would be 115 multiplied by 2 because we have 2 of them, and you add the calcium on top of that, which is 40. This gives you 270 grams of salt that is formed. Now we have done this many times, guys. I'm not going to go too much into the details. You already know it. So 8 is done as well. Now we are going to move on to the question 9. Okay, now in question 9 we have following information. It says that we have 100 grams of mixed phospholipid made from linoleic, lauric, and phosphoric acids. So in here we need to write down fully balanced phospholipid formation. Now linoleic is this one in here, and then the other one we have is lauric. Lauric acid is this one. So you need to write the reaction in here, which is gonna be giving you phospholipids. So we have glycerol, normally you shouldn't write the hydrogens like this, so I'm just gonna be an example here. And then OH, 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 and then we have lauric acid, CH210, CH3. So this is the one we have. And then we have linoleic, so I'm just going to copy it down. You will also have this table in your exam booklet. So it is 6 of them. And then you're going to write this one in here, CH2, CH, double bond CH. And there's 2 of them. And you have CH2, 4 of them, and CH3. And then you will add phosphoric acid, which is HO, PO, OH, and OH like this. And now we're going to combine them. All you need to do is get the water out from here. So I'm just going to do like this, and like this. And then I'm just going to combine them. H2C, CH, CH2, and I will do O, and then I have CO like this, CH2, 10 of them, CH3, and then CO, CH2, 6 of them, CH2, CH, 2 of them, CH2, 4, CH3, and then we have O, P, O, OH, OH, and you will create 3 moles of water. That's what you have. Now, for this one, you guys need to find the molar mass of everything. Unfortunately, this is gonna take a bit of time for you to calculate, so you will take this and you will find the molar mass of this portion, and you will find the molar mass of that. Okay, so the mass of the glycerol, it is 92 gram per mole. Mass of the phosphoric acid is 98 gram per mole. Mass of linoleic acid, it is 280.3, 4 gram per mole, and lauric, it is gonna be 200.3 gram per mole. Now you need to do hand calculation of all of this, and you're gonna add them up, and you will minus 3 times 18, which is 54 gram of water. So you would do 200.3 plus 280.4 plus 92 plus 98, and then you would minus 54 from that to find the molar mass of phospholipid, which is 670.7 gram per mole. So this is 670.7 gram per mole. That's what you have for the this mixed phospholipid. Now the question is asking you if you gram 100 grams of that, so we wrote this portion, and you're going to mix it with potassium hydroxide. Write down fully balanced alkaline hydrolysis reaction. Calculate the mass of KOH, potassium hydroxide, required. So now you have this acid. Okay, I assume that you guys already copied everything down in here. So we are gonna grab this acid. This is the second portion. Now, this is the acid we have. It's the molar mass of it. We're gonna use potassium hydroxide, and you know that we need to use 5 mole of it according to our question. And then what you need to get is the alkaline hydrolysis product. In this case, you're going to get your glycerol back, H2C, CH, CH2, OH, OH, and OH. And then from here you will get CH3, CH2, 10 of them, COO, negative K plus. And then you would get your linoleic acid. As you see, I'm flipping it as it is required from us. So you see we have the linoleic in here. Just gonna literally copy it as it is. So I have CH, double bond CH, CH2, 2 of them, and then CH2, 6 times COO, K minus. Now I couldn't fit this portion, so I'm just gonna take this. I know you can't do that in the exam, but so COO negative K plus. Oh, oops. So you will add that, and then on top of this, you're gonna get K3PO4, and you will get 2 of the waters out. That's what you have. Now, potassium hydroxide molar mass is, if you will check it out, it is 56 gram per mole. Now, since you have 5 of them, it would be 56 times 5, which is 280 gram. Now, we know that, so 670.7 gram of mixed phospholipid requires 280 grams of potassium hydroxide. And our question is asking, what if you have 100 grams of the mixed phospholipid? So this would be X gram of potassium hydroxide. You have 280 gram potassium hydroxide and 670.7 gram of mixed phospholipid. So you're gonna just do the cross multiplication and get the answer. X would be here. So it would be 41.7 gram of potassium hydroxide. Now, I highly recommend you redo this again, pause the video and do it for yourself, because a lot of you are making the mistake when they're writing the reaction. Now, question 10. It says, in the PPT following statement has been made. We already discussed very thoroughly with you in the class, but I'm still going to go over it. It says saturated triglyceride fats are solid at room temperature. On the other hand, unsaturated triglyceride oils are liquid because of their double bond. However, some animal fats contain unsaturated fatty acid, and some plant oils contain saturated ones. So even though we talked about saturated triglyceride, they make the solid ones, we can't make the conclusion that if it is saturated, meaning there is no double bond, saturated fatty acid does not mean it will be solid state. Okay, it won't be fat. It can be an oil as well. So we can't make that conclusion. But what we can talk about is going to be intermolecular forces. Now, if you guys remember, we had intermolecular forces such as London dispersion, dipole, and then we talked about hydrogen bonding. Now, in this case, we're just going to talk about the London dispersion, because London dispersion was only about the number of electrons. So it means the more the molar mass, higher the molar mass, higher the London dispersion force. For example, let's say I'm comparing you CH4 with C2H6, ethane and methane, right? Now, we know that because we have bigger molar mass in here, the London dispersion will be bigger and they will attract each other more. So as the London dispersion, as the molar mass goes high, London dispersion increases, and this means our density will increase. And as the density increases, it will increase the melting point, and it will increase the boiling point. This should all make sense because we have done this in the last term as well. Like, because molecules are attracting more each other stronger because of the stronger intermolecular force such as London dispersion. Like, London dispersion forces in itself is not that strong as hydrogen bonding, but in general, if we're comparing the two, the one with more London dispersion, meaning the one that is saturated, so saturated ones will have more molar mass, right? Because we have more hydrogens. So we can make this conclusion: molar mass higher, meaning the ones that are saturated ones will have stronger London dispersion, which will increase their density and which will increase their melting point and boiling point. Okay, you can make this conclusion for yourself. Okay, and that is the end for the question 10. Now question 11, guys, over here I haven't listed the questions. The main thing in here is that you need to be able to draw the steroidal backbone, fundamental structure of steroids. That you know that there are 6 rings and stuff. Like, you need to draw it all. Also answer all of this question using the PPT. That's all I can tell you. Just there are 2 pages. You just go through them, take notes, and answer these questions. Now, question 12, it says identify the names of the following carbohydrate structures, indicate to which type of classification they belong. Now, quickly I'm gonna go through this. Is that if you open the structures, first of all, we need to recognize them. The one in here we have is alpha glucose. You guys need to be able to recognize it because we have done this. So this is alpha glucose. The way we can identify when the OH of 1 and 4, they are on the same side. Now, the one, if we want to draw the beta glucose, all you need to do is get this OH up here, and that's it. So the way it will look like, just basically instead of here, we will have the OH and we will have an H here. Okay, that would be beta glucose. Now, the one we have in here is alpha fructose. And again, if you want to change it to make it beta, so this is the first carbon, this is the second, and third, this is the 5th carbon. All you need to do is that change this position to here, to bottom, and OH up. Okay, and this would be a beta fructose. I want you to draw the structures and be familiar. You need to be able to look at the picture and recognize them. The one in here on the after is alpha ribose. The same thing here. You just the same thing with beta. All you need to do is get this one up, and this would be a beta ribose. And then the one in here we have is deoxy, alpha deoxyribose, and then it just deoxy means because this OH is not there, and OH is gonna go up and it will make it a beta. There is one more that I want you to learn, is called galactose. But before we go, I want you to look at this ones. Alpha glucose, we have glucose, fructose, ribose, deoxyribose. Now, when you classify this, we know that glucose is hexose, and but it is an aldehyde, so it is going to be aldohexose. And then fructose is, on the other hand, it is ketohexose, and on the ribose we have pentose, but it is gonna be aldopentose because it is an aldehyde. And then deoxyribose is also gonna be aldopentose. aldopentose. If you will check out all the structures, they are on our PPT. They're a straight chain. You can see it on the slide 85 that I shared with you. Okay, and then so about the galactose, the structure of galactose, we need to also draw that one. Now galactose looks like this. We're gonna have OH up here, OH up here, CH2OH, and then we have OH down, and then OH up. So all of the pretty much all of the OHs are up except the one on the second carbon. Okay, now this is galactose. Although this is a beta galactose, I should have thrown you the alpha. Just a second. So when you have OH down, this is alpha galactose, and if you wanted to draw the OH up, the one I drew before, it's going to be beta galactose. Okay, so know all these 5 structures and you would be fine. Just know how to make them alpha and beta. It will do the work for you. Now, that being said, I want to move on to the question in here and then come back to the other ones. So this structures is the combination of the monosaccharides we had. Now you can see that this one in here is alpha glucose, made from alpha glucose because OH was down here and then they condensed. And then we have another alpha glucose. And when alpha glucose and alpha glucose make a disaccharide, the disaccharide it's called maltose. Okay, so you write alpha glucose plus alpha glucose gives you maltose. Now the one we have in here, you can see that it is beta galactose, and then we have the other one in here is beta. It is beta glucose. So beta galactose and beta glucose, when they combine together, they give you lactose. This is also in your PPT on the page 88, and then we have this one in here. We have alpha glucose, and then we have, you can see the structure itself in here, it is beta fructose. When alpha glucose and beta fructose combine, it gives you sucrose. So you need to know the structure. When you see them, you gotta be able to recognize them right away. Okay, so that's what we have for question 15 is done. Now in question 13, it is asking us to write the formation of starch, cellulose, and cellulose trinitrate using the cyclic structures. So I'm gonna start with the starch. I want you to pay attention carefully because they are looking very similar, but they are actually different. Now we know that starch is made from alpha glucose, cellulose is made from beta glucose. So let's write alpha glucoses. So we have in here 2 of them. I will write in here 2 of the alpha glucoses. So alpha glucose looks like this. Now when we make the bonds between them. The way it's gonna look like, we will get the water out of here. So I'm gonna remove this stuff, and here we have only oxygen left. So the way it will look like, this part is very important. It will connect through here with the oxygen from the bottom, and the ones in here, they will look like the same. It will be all like this, and it will continue. Now this is your starch made from alpha glucoses. Okay, you need to make sure that you draw it correctly. And now we're gonna do it for cellulose. So we will do the same thing here, but with the beta OH in here is up, the rest is the same. And then we have another one up, and it's gonna be OH down, OH up, down, CH2OH. Now when they will connect, we're gonna get rid of the water, so that it doesn't matter from which one we take the oxygen off. We're gonna delete this area, and when we connect it, it's gonna be going from the up and coming from the bottom for this one. And this one's in here, it will become oxygen from the down and oxygen from the up, and it will go like this, and this is your polymer for cellulose. Okay, and when you make your cellulose trinitrate, all you need to do in here, it's gonna be, you will add HNO3. When you will add the HNO3, the structure, if you check out the PPT, you will see it. So now, once you copied this down, I want you to pay attention to here. You will connect your, so this oxygen in here, NO2, and then here NO2, then NO2, 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 and then NO2. Now this is your cellulose trinitrate in the cyclic structure. Okay, so that is the question answer for 13. Now it's asking you to calculate the mass of cellulose trinitrate formed from 1 kilogram of cellulose. In this case, you don't actually need to draw the cyclic structure because it's not asking you for it. So we're gonna start with cellulose. They basically want you to draw this portion, like make the calculation on this portion. But we know that the cellulose is C6H10O5, so this is N amount, right? And then we will add 3 times more HNO3, and what we will get out of here is gonna be 3N times of water, and we will get C6H7O2, and we will have 3 nitrates. So I'm gonna draw exactly the one from your PPT. So C6H7O2 with ONO2, ONO2, ONO2 here, and this is N times. Now, before we move forward, I wanted to kind of write this stuff in here for cellulose, just a compressed version. I have 6 carbons, I have 7 hydrogens, we have in here 2 oxygens, and then 3 in here, and then we have 6 in here. So 2 plus 9, 11, and we have N3. So this is the N times. If we write it, so now let's write this one, C6H10O5 N times, and we have 3NHNO3, giving you plus 3N water. Now just concentrate on the bottom part. Let's find the molar mass of cellulose. So we got 6 carbons, which is 6 times 12, 10 hydrogens, 10 plus 5 times 16. Now we have in here 72 plus 10 plus 80. And this will give you 162 grams of per N. In here it is 162 gram. Now you will need to write it by times by N, and then HNO3 molar mass is 63, so you would do 3N times 63 grams. This is the ratio that we have. The question is asking, calculate the mass of cellulose trinitrate formed. Now cellulose trinitrate formed, we also need to calculate this portion. So carbon is 12, hydrogen is 7, oxygen is 11, and nitrogen is 14. If you do the calculation, which is 297 gram times N. Now, these are the ones that we need in this ratio. So we have 162 gram times N gives you 297 gram times N amount of cellulose. What if you have 1000 gram of it? X gram of cellulose trinitrate will be formed. Now you do this over that. This will give you 162 times X times N. This will give you 297 times N times 1000. Now N and N, they're just going to cancel out. X will be 297 times 1000 divided by 162. And if you do that calculation, you will get 1833.3 grams of cellulose. Okay, so this is the value you get. So for 1 kilogram of cellulose, you make 1.83 kilogram of cellulose trinitrate. So I'm just going to write it shortly like this. I want you to practice this calculation. I know that if you do it multiple times, you're going to get it. It's just a simple stoichiometry. Don't worry about the N in here. They will always just cancel out. Okay? So that finishes the question 14 for us. And then we got in here question 16. It says calculate the mass of glucose made from hydrolysis of 100 grams of sucrose. Now sucrose is basically just a condensation of 2 glucoses, right? So it's just 2 times C6H12O6. That gives you out 1 water. If you will take it out, you will get C12H22 and O11. That's the sucrose molar mass. Molecular formula, the molar mass would be 342 gram, which is also makes sense because you have 360 gram in here and 18 gram over here. Now, It says calculate the mass of glucose made from hydrolysis. Now the hydrolysis is just the same reaction but going backwards, right? So if we do a C12H22O11 plus H2O gives you 2 glucoses, right? In here like that. So we know that 342 grams of that gives you 360 grams of this. We need 18 grams of water. What if you have 100 grams of this? You would get X gram of glucose. So that's your math calculation would be X equals to 360 multiplied by 100 divided by 342, and this will give you 105.3 grams of glucose. Okay, and that is that for question 16. So question 17, I'm not going to go into the details. You need to go through all the steps in our lab guideline. We have it for you there. Just go through them. What safety precautions you will also need to look into that, or maybe Google what kind of things we're working on and where can we hurt ourselves. And question 18. Now this is maybe something that is mind-boggling for some of you, but overall in here, if you remember in our Benedict test we had certain colors, right? And it all started with the blue color from the Benedict reagent, and then it will turn into some other colors. So we have in here green color, which is 0.1 to 0.5 percentage by mass of glucose. Over here we have 0.15 to 1, which is yellow. We have orange, red, and brick red. So this is 2+% by mass. Now, in here, let's say we're given a sample that has 0.3 gram glucose dissolved in 10 milliliters of water. Now, we have a solution. And it's that has 10 milliliter of water. Inside we have 0.3 gram glucose. It says what color change would you expect when performing Benedict test with 1 milli of that sample. So we just have a solution in our hand, which is 10 milliliters, has 10 milliliter of water and 0.3 gram glucose. Now 10 milliliter of water, you know that the density of the water is 1 gram per milliliters. So mass of the water would be just a 10 milliliter water would be just a 10 gram. Okay, so we have our solution, that is, so our solution is 10 gram water and 0.3 gram glucose. Now let's try to find the mass percentage of glucose in here. Glucose, it would be just a 0.3 gram divided by 10.3 gram of solution, right? Or you can, if you have a big volume of water, you can just keep it as just 10 gram. It's not going to make a lot of difference. So we're going to have 0.3 gram of glucose over the water and multiply by 100%. And from here, your answer would be just a 3%. Now 3% is more than 2%, which is the maximum range we have here. Because for this one, it is 0.1 to 0.5. This one is 0.5 to 1. This is 1 to 1.5. This is 1.5 to 2. And this one is 2 point and above. So because we have this percentage, it's going to be brick red. Now let's do it for this sample. We're going to do it for A and B in here. I don't want you to get confused when it says 1 milli of that sample. We're basically just checking using 1 milliliter of it, okay? Once we find the percentage, that's going to be the color for that 1 milliliter, because it's just a sample taken from that. Okay. Now we have in here 5 grams of glucose, 200 milliliters of water. It is just a 200 gram. And then if you would do 5 over 200, if you want, you can do 205. It doesn't matter. It's not going to make a lot of difference in the color. So this would be 5 over 200 multiplied by 100. So this one is 2.5%. For fun, I'm just going to do it with the 205, just to mask the whole of the whole solution. 5 over 205 multiplied by 100. This is 2.43, 44%. So it is again more than 2%. So this is going to be a brick red as well in the color. And if we check out 10 grams of glucose in 1 liter of water, so now 1 liter of water is 1000 milliliters. Now we know that this will be 1 kilogram of water, which is 1000 grams. Now if you have 10 grams of glucose over 1010 grams of solution, or you can just do 10 over 1000 over 100%. Multiply by 100%. Just for sake of the exam, I would stick with this one, okay? Although I said don't worry about this 5. Actually, don't use this method, okay? In order to make sure that we have the whole thing as we planned, just make it 205. Like add the mass of the glucose into the solution and take the mass percentage like that. We have 10 grams of glucose with 1000 grams of water. It would be 10 over 1010 multiplied by 100, and this will be approximately 1%. Now 1%, let's see where does it fall. 1% falls into the yellow, like it's like end of it is yellow, and then just above it is orange. So because it falls into exactly the range, we're gonna say the color is gonna be yellow to orange, and you need to justify because the reason it's yellow, because from 0.5 to 1%, 0.5 to 1% it is yellow, and then 1 to 1.5% it is orange. So it is like yellow orangish color, the combination of both. Now everything else is just the same Benedict test. All you need to do is know how to do the mass calculation. In here again, when you did the solution of 0.3 gram, I'm just gonna fix it in here. So make this 10.3 gram, and if you will do it 0.3 over 10.3, so this is approximately 3, but if you do exactly it is 2.9%, which is again more than 2%. Okay, so I wish you guys good luck. Tomorrow is an important exam. As you can hear from my voice, I got pretty tired, but it's worth it. I want you to guys succeed. Please go through all of the questions many times, specifically question 13, 14, and then the last question I did, question 18. This will help you out a lot. Take care. Good luck.